right, we're going to move on to a new section. And what we're going to talk about are what we call our perpendicular and angle bisectors. So you are familiar with what a bisector is. You know that an angle bisector would split an angle into two congruent angles. And if we had a perpendicular bisector, you know then that you are going to be working with a right angle. So when we talk about the perpendicular bisector, we're talking about where your bisector hits your line segment at a 90-degree angle. So our topic today will be how do we use the perpendicular and angle bisectors to find either our segment lengths and our angle measures. So you're going to use the knowledge that you already know about bisectors as we go into this concept, so you'll have a better understanding of it. Okay, we're going to start off with the perpendicular bisector, and we are going to be working with our theorems. All right, your perpendicular bisector theorem states that, and here it is, if a point is on the perpendicular bisector of a segment, then it is equidistant. And equidistant, what does that mean? It means the same distance from the end points of the segment. Let's come over here and take a look at our picture. First of all, we have segment FG. It's a segment, right? Because it has the end points. Now right here you see the 90-degree angle. Line L is the perpendicular bisector. We know they're perpendicular. How do we know it is a bisector? You see your tick marks? So perpendicular, and it is a bisector because we've been given our tick marks. So we know that the distance from F to B is the same distance from B to G. So therefore making line L a perpendicular bisector. So if we know that it is a perpendicular bisector, this point A right here, we know that A is equidistant to the endpoints. In other words, the distance from A to F is going to be the same length as the distance from A to G. And I'm just going to go ahead and put in 2 tick marks so to show that. And that is what your perpendicular bisector does. You can also see here, I want you to kind of also notice that when we put in these distances here, do you see that you actually get a triangle? And we will talk about that further. Now, I also want to point out here that the converse of this theorem is also true. Okay? So what would that mean? That would mean if a point is equidistant. So if you start off with the fact that this point is equidistant, so you would start off with this fact right here. If this point is equidistant to the endpoints, then you're going to be able to conclude that this line will be the perpendicular bisector. All right, so let's look at some examples here. All right, we've got some markings here. We see that we have our perpendicular because of the angle here, and we also have tick marks. So what do we know? Well, by this tick marking, I know what about the distance from B to S. I know that it is also 14. And since I know that these are congruent to each other, I know that this is a bisector. I also know that it is a perpendicular bisector. So we go back up to our theorem, and we can see then, okay, so if this is the case, I know that this point is equidistant. So I transfer that thinking down here. So if I have this point R on that perpendicular bisector, I know that it is equidistant to endpoints T and S. So I'm just going to put my tick marks in. So then I know that the length or the distance from R to T is the same as the length from R to S. So we know then that the length from R to T is 16. All right, let's take a look at our second one. We want to find the length of segment AB. So let's go up here and find it. The length of segment AB. So actually we want this whole thing. I'm going to go ahead and just kind of do a little marking here. Okay, what do we have? I have some tick marks. So the length from A to C is the same as the length from A to B, which is 4. Okay, so what do I know here? I know that C is equidistant to the endpoints of A and B. Okay, so I know that. They also gave us a 90-degree angle here, so we're going to use our converse. If we know that C is equidistant to the endpoints, then we automatically know that line CD is the perpendicular bisector. So that means from A to D is congruent from D to B. So I now know that D to B is also the 2.5. Therefore, I know from A to B, all I have to do is add those together and I get my 5. And let's take a look at our third one. They want us to find the length of H to J. So we're actually wanting to find this length here. What do we have? We've got tick marks. So we see that from J to L is congruent from L to K. And we're also given our 90. So we know then that this is the perpendicular bisector. Then that means what about H? We know that H then is equidistant to the endpoint. So I'm going to put in tick marks. So if I want to find H to J, we have to find our X. So you know what you're going to do next. You're going to set up an equation. You know that these two are congruent to each other, so that's what you're going to do. So we set those equal to each other. We're going to get our X's to one side. So you're going to move your 3X over. And then you're going to move your negative 3 over as a positive 3. So we get 4 equals to 2X. So now we know that X equals 2. And then we're going to put that right in. And we're going to do 3 times 2 plus 1, or 7. So we get the length of HJ is 7. Okay. Now let's move on to our angle bisector. We also have a theorem for our angle bisector. Okay. And if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So let's come over here and take a look at our drawing. Here is point P. Okay. We are given that ray MP is the angle bisector of angle LMN. So what do we know? We know then that these angles are congruent to each other, so we'll put in our tick marks. Now, one thing I want you to make note of, we've talked about, remember when you measure a length or a distance, remember it is always measured at that 90-degree angle. So that is why those are in there. This is the length that we always measure, perpendicular distance. So then we can conclude if this is the angle bisector by our theorem, we know then that the length of L to P and the length of N to P are congruent. So I'm going to put the tick marks in. The converse of this is true if a point in the interior of an angle is equidistant from the sides. So then you start off with this fact. You start off with the fact that these are already congruent. Then what are you going to be able to conclude? You're going to be able to conclude that this ray, MP, is the angle bisector, and therefore then you can conclude then that these two angles are congruent to each other. All right, so let's take a look at our situations here. We're going to find the measure of E to H. E to H, we're given the fact that you have these angles that are congruent to each other. So we know then that this is a bisector. Therefore, we know that H is equidistant, point H is equidistant to these, to the rays that make up your angle. Therefore, if HG is 23, we know that E to H is 23. Our next one, we're given the fact, actually now we're going to do the converse, we're given the fact that T is equidistant. Therefore, we know that these are congruent to each other. If we want to know what QRS is, well, if we know this one's 25 and this one's 25, then we know that that total would be, 26 and 26, we know that that total would be 52. And then our last one over here, we want to find the measure of angle WXZ. WXZ, we want to know this one. Our information that has been given to us is the fact that Z is equidistant to the sides of the angle. Therefore, we know then that this XZ, ray XZ, is the bisector. Therefore, we know that these angles are congruent. So we'll set them equal to each other and we will solve it. So we move our 2x over here and we would move our 25 over, giving us 30 equals 2x. Therefore, x is 15. We want the measure of angle WXZ. WXZ, we want the measure of this angle here, so we'll substitute in that 15. So 2 times 15 plus 5, we get that measure angle of 35. All right, I want you to turn your worksheet over, and I want you to use these theorems to work the problems on the back of your worksheet. This will be due at the beginning of class.